Hi, I'm Sergey from AWS. In this video, we'll talk about optimization, which is the last stage of migration process. As we've seen in our prior videos, migration is a complex process with a lot of moving parts, and most customers need assistance in their journey to the cloud. Migration paths can vary from lift and shift through deep refactoring of cloud-optimized applications, so the end result is not necessarily always the most optimal with regards to performance or cost efficiency. The objective of an optimization stage is for partner to help the customer adopt and integrate application best practices of cloud-native applications. As part of this process, you can assist the customers with providing training, workshops, proof of concepts, application design, or even architectural guidance. You can definitely leverage AWS resources at this stage. Aside from extensive documentation, workshops, and training materials, you can use AWS ProServe teams to help you assist your customers. In optimization stage, we can start working on enhancing the efficiency of running workloads in AWS. Typically, optimization receives most attention after the migration, but we should think of optimization throughout the migration cycle and find ways to optimize performance or cost during all stages of the migration. Let's take a look at some of the ways we can approach optimization. For application optimization, we recommend leveraging managed AWS application services to help achieve optimal scale and cost efficiency, like S3, RDS, DynamoDB, and others. Services like S3, for example, are used by millions of customers and provide a cost-effective solution at lower management overhead. In addition, managed services like S3 or DynamoDB are designed with scale in mind and would allow you to meet your future performance needs, so you won't have to worry about performance demands of tomorrow. Process optimization might involve improvements to application deployment, such as CI/CD. One of the popular ways to build and deploy applications is to package them as containers. Using automation, packaging your application as a set of containers during build process and utilizing services such as Elastic Beanstalk or Elastic Container Service allows better EC2 resource utilization, security, and out-of-the-box version control through EC2 Container Registry. From the point of view of operations, cloud allows a whole new way of thinking about it. We no longer need to maintain racks of servers or deal with routers, switches, or any physical equipment, and combining flexible on-demand capacity deployment and full automation provided by AWS and tools like CloudFormation, you can now model your entire cloud footprint as a set of templates, which is just plain text YAML or JSON files, and just commit them to your source control repository. Deploying your entire infrastructure, networking, security, EC2 instances, and all other resources can be done automatically from your templates. Change to an existing environment can be applied in the same way through the process of updating infrastructure templates in your source control and subsequently deploying them through CloudFormation. This allows precise control of all your changes to your infrastructure and minimizes any errors or discrepancies related to manual changes. As far as cost optimization, reserved and spot instances could be a great way to optimize different workloads with either long-term compute capacity needs or save costs on resumable workloads that could sustain temporary interruptions. Understanding your application requirements are key here. Optimization is an iterative process that continues throughout the lifetime of application in the cloud and is essential to realize the full potential of the cloud. Fine-tuning your application always starts with monitoring. Whether you use AWS CloudWatch or AWS Partner Solution, you need to think of how you will gain insight in your application health and performance in the cloud. Take a look at your model for capturing, storing, and analyzing log files produced by your applications. Because instances come and go, storing logs locally in the long term is simply no longer appropriate. CloudTrail could be one way to accomplish this and is also integrated with CloudWatch, so you can monitor incoming log entries to surface the results as CloudWatch metrics and alerts. Once we set up our data collection and identified key metrics, we can start working on application optimization. Again, the key here is to focus our optimization efforts. We recommend leveraging AWS application services to achieve optimal cloud footprint. AWS application services such as S3 or DynamoDB are used by millions of customers, so they take advantage of massive economies of scale that are passed directly as savings to AWS customers. In most cases, you would be able to reduce your application costs if you leverage AWS application services in your application design. As an added benefit, you will also get improved scalability, mitigating the need to worry about the future performance needs. It gives you out-of-the-box fault tolerance and improved resilience. Typically, In lift and shift migration scenarios, application architecture remains largely unchanged as it moves to the cloud. Lift and shift takes an existing on-premise application and replicates it to the cloud, so monolithic applications do not automatically become service-oriented just by the fact they now run in the cloud. In such cases, consider discussing microservices re-architecture with your customers. Microservices buys you a lot of flexibility and agility because each service can be deployed, tested, and developed separately, especially if the service is decoupled via asynchronous messaging. The downside is increased complexity because your software system now has many more moving parts than a monolith, but the upside of scalability and agility is well worth the effort. Typically, when switching to microservices architecture with many moving parts, you will quickly discover that your deployment build processes need to scale as well. CI/CD or continuous integration, continuous deployment can help here. CI is a development practice that requires developers to integrate code into shared repositories several times a day. Each check-in is then verified by an automated build, allowing teams to detect problems early. This process of frequent check-ins followed by continuous automated build and acceptance testing significantly reduces cost and wasted effort. In addition, CI allows the businesses to quickly adopt new features and rapidly course-correct based on changing business needs. Microservices architecture combined with good CI/CD processes can help achieve better cost efficiency and scalability. It also provides greater agility by being able to iterate quicker and deploy in frequent small batches that have small effect on overall system stability. As we've seen, architecture best practices such as microservices, along with procedural improvements such as CI/CD, are some of the popular ways to optimize cloud-first applications. AWS offers many other options. Overall, optimization is a continuous iterative process with many different tools and options. However, as before, we recommend keeping optimization efforts driven by data analysis to keep sight of the target and making sure that the optimization effort produces the most impactful results. In this video, we took a look at optimization stage, which is the last stage of the migration process. And we discussed some of the ways we could save cost or introduce operational efficiency in the cloud-enabled applications. At this point, we reviewed all stages of the migration process and all the necessary ingredients of the migration. We hope that you will find this material useful in planning your future migrations and helping your customers succeed. Thank you for watching.